Right, let's look at how electrons are filling in atomic shells. If you have a question and if you have doubts of how many electrons in each cell, all what you need to remember is get the golden rule. It will help you. No trouble. Let's see the first one. If you think the number of shells is n, right, then when n equals 1, meaning it's just the first shell, you will end up with maximum 2 electrons. Remember, this first shell is the one closer to the nucleus. Now the second shell, n equals 2, which can have maximum of 8 electrons. Now the next is the third shell. It can have maximum of another 8 electrons. And the fourth shell can have maximum of 18 electrons. We are writing in short, starting from the first one, the one closer to the nucleus, 2, you can put a forward slash or comma. Then the next second shell, 8, again forward slash or comma. The third shell, 8. And finally, after another forward slash or a comma, you will be writing 18. Let's do an example. 20 is for magnesium. For calcium, you're right. Okay, 20 is for calcium, right? 20 is atomic number. So how is the electron spread? The first shell got 2, the second shell got 8, third 8. Now altogether becomes 16 or 18. 8, 8, 16 plus 2, 18. And remaining 2 electrons. That 2 is the outermost shell. Let me circle this 2 outermost shell, because once you know the electronic configuration, the next important stage is how many electrons are there in the outer shell. So as in this case, there are only 2 electrons, right? Now what we are going to do is, we'll draw some Lewis dot diagrams to show that 2 electrons are present in its outer shell. So that big arrow is going to draw the Lewis dot diagram for calcium, right? So the writing is clear. Remember, outer shell, another name is valence shell. Here comes calcium. So it should have how many dots? 2 dots, because the outermost shell got 2 electrons. Here's one and here's the other one, right? So that's fine. So that's quite easy. And you can see that if it is the calcium is in group 2, so all the elements in group 2 will have 2 electrons in their outer shell. Now let's see what's going to happen with these 2 electrons, right? Because it is not happy right now for the reason that it's not stabilized. It wanted to become stabilized like inert gas, right? So inert gases are, the inert gases, another word is noble gas. Noble gas is the royal family style. They don't want to take electrons from anybody, and they don't want to give electrons to anybody. So what calcium is going to do is, as it is not stabilized, it wanted to reach to noble gas level, that status. To do that, it has to give these electrons to someone who is willing to take. Then the calcium, once this calcium 2 electrons are gone, what is next is 8, right? So that means calcium can be stabilized. But the problem is there must be someone to take that electron, right? You are going to find out that for me. So here the 1 electron is going out, right? When electron, remember, electrons have negative charge. When 1 electron is losing, meaning the positive charge is increasing, right? 1e, 1 negative goes out, meaning there is a 1 positive charge. Remember that. Now let's see what happened to the other electron here. Okay, and here it is. That electron is, again, it is also going to give out to reach the stabilized stage, right? The last 2 electrons need to be given to somebody there. Now what happens is calcium will have, it is losing 2 electrons, meaning 2 negative charges. So that means overall charge becomes positive, positive 2, right? And here the final result, calcium positive plus 2, that's called calcium ion. So I hope this is crystal clear, the formation of ion, and it is very important from hereafter. Now look at this 2 electron, where it's coming from, right? It's in the group, it's group 2. That's why last shell got 2 electrons. Look at the ion it's going to form. That is plus 2 because this 2 has to give out. There it is. So this shows the real connection with these 2, the ion and the electrons in the last shell, right? That is the character of group 2 elements. Here comes group 2, right? You can call it one of the properties. I hope this is clear. Right. Let's look at how we are going to write some ions which are formed from elements. There are 2 methods of forming ions. Method 1 is to give electrons to somebody. Number 2 is getting electrons from somebody. Now, why these elements want to give or get electrons? The reason is, except the elements in the 8th group, all the rest of the elements do not have fully completed outer shell, right? Because the number of electrons in the outer shell vary from 1 to 7. But to become stabilized, it has to be either 2 or 8 mainly. And you know that clearly, the noble gas, as the name states, they have all the electrons they need. So they are stabilized, they don't have any issues. The issues are with the majority, the commoners, right? Let's get examples, one at a time. And let's find out some connection between ions formed with the number of electrons in the outer shell. Okay, those are handy tips, remember, getting ready for the exam. First example, let's consider sodium. So sodium, the atomic number is 11. So how do we write the electronic configuration? Following the Bohr diagram, we are getting into short, using the golden rule. First shell got 2 electrons, the second shell got maximum of 8. So sodium can give 10 electrons already it has given. So what is left is simply 1 electron. Now we are going to draw the Lewis dot diagram. To draw Lewis dot diagram, Lewis was concerned about the electrons in the outer shell. Here I'm going to circle that. That's what we need, right? So we are going to draw now the Lewis dot diagram for sodium. So let's write first sodium. Now we need how many dots? Simply 1 dot. Here we go, right? Now, because of this 1 electron in its outer shell, it is not stabilized. So it has to give that 1 electron to someone. So when this 1 electron is no longer there, it will have 8 electrons in its outer shell. So that means it is stabilized. So sodium is going to give this 1 electron to somebody, or it can have 7 electrons from some other element. Now, if you look at this, you can weigh this, the 2 sides, giving 1 electron versus getting 7. Of course, the easiest is giving 1. Getting 7 is hard because giving 1 electron loses a lot of energy. Getting 7 meaning amount of energy that the other element is going to lose is 7 times more. So either way, easiest is get rid of the single electron. See what happens when it is giving this electron out of sodium, right? So when electron going out, meaning 1 negative charge is now reduced. When the negative charge is reduced, what happens is the overall charge becomes positive 1. Now here that electron is going to give out. So it will end up with finally a positive charge, which we call sodium ion. Now we need to find out a connection. Remember I said the connection between the electrons in the outer shell and the kind of ion going to be formed. Let's see what's going to happen. There that the electron in the outer shell, and here the sodium ion with plus charge. So this is a property of elements in group 1. Right. Now let's get another example. Now your job is to keep an eye to find partners. That's the important thing, right? So keep an eye on the big picture when I am doing these housekeeping jobs, right? Let's get another example. Aluminium having atomic number 13. So 13 electrons, meaning following the golden rule, you will be distributing these electrons. The first shell can have maximum of 2. The second shell can have maximum of 8. Now 8 plus 2 equals 10. What is left is simply 3 electrons. That 3 will go to the outer shell. So let me circle these electrons in the outer shell because that's what is important to draw Lewis dot diagrams. Now let's draw Lewis dot diagram for aluminium. Here's aluminium. How many dots do I need? Only 3. 1, 2, 3. Right? Now aluminium having 3 electrons in its outer shell is not stabilized. Right? It wanted to reach to the noble gas status. To do that, what it could do is it has 2 options. Either to give these 3 electrons out or to get 5 electrons from another element. When you weigh these 2 sides, giving 3 and getting 5, obviously the easy choice is giving 3. So it's going to give 3 electrons. Remember, electrons are negatively charged. So each electron meaning negative 1. So when one negative is going out, meaning overall charge becomes positive. Can you remember the protons and the neutrons in the nucleus? Neutrons meaning protons and electrons together. So it is neutralized to begin with. Now, as it's losing electrons one at a time, let's see, look at, compare with sodium. Sodium is losing 1 electron and ended up with 1 plus charge. Now, here comes aluminium. It's losing 1 electron. Okay, so it should, now when this one goes out, it has to have 1 plus. And here it is going to give out another electron. So then means it should have plus 2, right? And it is going to give the third one out, right? And that should end up with plus 3, right? That's what the charge of aluminium is. So here we form the aluminium ion. You can say, write down plus 3, but that is awkward. We don't write, right? The conventional method is writing Al plus 3, right? That's the aluminium ion. Now let's find a connection with this ion formed and the electrons in the outer shell. See what happens. I got 3 electrons in its outer shell, and here I have this ion Al3+. That is a property of group 3 elements. Here we go. Right? Now I have done 2 examples. I hope your mind is right now looking for partners, okay? You have to find a partner for sodium, partner for aluminium. That's the next big job. Let me get one more example. Now, these in both cases, I considered electrons giving out to form ions with positive charge. Remember, positive charge ions are going to cathode. We call it cations. Third example is a different one, considering chlorine, having atomic number 17. So let's distribute electrons to each shell. Use the golden rule I have told you earlier. First shell is with 2 electrons, second shell with 8 electrons. Now that number total is 10. what is left is 7 electrons. That goes to the last shell. So let me circle the last shell, right? So what I'm going to do is going to do the Lewis dot diagram. It has to have 7 dots, right? Here 1, 2, 3, 4, 5, 6, 7. So it has 2 options to become stabilized, either to give 7 or get 1. As like earlier, you weigh these 2 options. Of course, getting rid of 7 is losing so much energy and it's not going to happen. Getting 1 is pretty easy, right? So it has to have 1 electron. That means a negative charge coming in. So that means with that additional negative charge, it becomes 8 electrons here. That means it will be stabilized by getting electron. So the ion formed, unlike earlier, giving out electrons will make positive charge. Getting electrons has to have negative charge. Here the chloride ion, remember from chlorine, the ion formed, we call it chloride ion. If you look at this diagram clearly, you should be able to find partners. I'll let you think about that. We are going to find out partners for charged ions. Let's get one example we have done a few minutes back. That's sodium. This is recalling your memory. You knew that? It was to deal with the electrons in the outer shell. So we are writing dots based on number of electrons in the outer shell. In this case, it is 1 dot. So when sodium gives then that electron out, it will have a positive charge. Here the electron giving out, and here the charge. So that's a sodium ion, right? So sodium ion is in group 1, right? Only group 1 elements can form ions with 1 positive charge. The next example was, I hope you could remember chlorine. It's a different one. So chlorine had 17 electrons. The atomic number was 17, and the electrons were spreaded in 3 shells, having first one 2 electrons, second one 8, and the left is 7. This is following the golden rule. Now we are going to consider only the electrons in the outer shell. Let me circle that. Now that number, number 7 is the one we are going to consider to draw Lewis dot diagrams. Here chlorine. I need 7 dots here. I did this few minutes back. So here comes the 4, 5, 6, 7. So it's clear it has to have 1 electron from another element to reach the stabilized state. Electron getting in meaning it's a negative charge. It has already 7 negative charges, right? 7 there, right? But that 7 is chlorine, what chlorine has under normal conditions. What it is going to have is 1 negative charge, 1 more negative charge. So because of that, remember it formed a chloride ion. Remember I said chloride ion? Now if you look at that, look at this. These things are ideal match, don't you think so? Because sodium is it's ready to give electron, and chlorine is readily there to accept that electron. Can you see this match? So sodium can easily coupled with chlorine. Why do they do that? They can form a compound. Okay, so before getting into compound, let's see, this is 7 electrons outside. So don't expect group 7 here, because group 7, it is true it's group 7, but it is forming negative, that means negative 1. So remember the pattern now. Group 1 is with positive 1, the charge of all the elements there. But group 7 will have negative 1. And that is the beauty. Okay? Now look at these two. I got a yellow arrow here, sodium and chlorine. That is very well matching. So as a result, what happens? They are getting together and forming a bond, which we call ionic bond, right? And the name of the compound is, we call it sodium chloride. This is what you have in your kitchen, the salt we eat. And I put a happy face because both are stabilized now, right? So they have reached to the status of the inert gases or the noble gas level because stabilized, right? So that's what we did. We were matching partners, right? And we found the ideal partners here. Ended up with a happy bonding, right? And we call it ionic bond. That's one example. We are going to do another example, right? The next example is, let's see what's the next one. We'll get aluminium as an example. I have done a few minutes back. So its electronic configuration is 13 using the golden rule. First shell got 2, second shell got 8. What's left is only 3 electrons. But for to draw Lewis dot diagrams, I'm concerned about the electrons in the outer shell, and here it is circled. So let's draw. This was done. This was repetition. Here aluminium got 3 electrons in its outer shell, and it's going to give these electrons out. 1 electron going out meaning 1 positive charge. Another electron going out meaning it has 2 positive charges. And with the third one going out, it will have 3 positive charges. Here it is going to form aluminium plus 3 iron, right? And we said that the outer shell electron and the form of ion formed, that's equal. So it's a property of group 3 elements. Now let's get a different example. Nitrogen. Nitrogen got only 7 electrons. Atomic number is 7. So that means using the golden rule, first shell got 2. What is left is going to the second shell. The second shell could have maximum 8, but this got only 5. So it's not stabilized. We are going to draw Lewis dot diagram for nitrogen. So it is what is important is the electrons in the outer shell. Here's nitrogen. I need to draw 5 dots. 1, 2, 3, 4, 5. So to become stabilized, it needs to give this 5 to another element or getting 3. It's always easy to get 3 from another element. Okay. Now remember that getting electrons meaning having negative charge. This is right now. Right now nitrogen is neutral atom because in its nucleus the protons and the electrons are equal. So that's why it's neutral. But having 1 electron will give it -1 charge. And having another electron gives another negative charge. That means -2. And having another electron will give another negative charge. Altogether, 3 negatives. 3 negative charges. That's a big one. So the ion it is going to form is N-3. We call it nitride ion. Not nitrider. This is nitride ion. And look at the connection now. Here, having 5 electrons in outside does not mean that it is belong to 5th group. In that case, it is opposite of aluminium, right? So yes, it is in the 5th group, right? But it is getting 3 electrons. Now, if you look at these aluminium and nitrogen, remember aluminium ion and nitride ion. Aluminium is ready to give 3 electrons. Nitrogen is ready to get 3 electrons. That means they two should be matching together, right? So that's another partnership, right? Let's put these two with the bridge, yellow bridge. Here comes the yellow bridge. And they are going to form an ion because +3 and -3 becomes 0. It's well balanced. And then they are forming an ion, which we call aluminium nitride. Okay, that's the ion. So happy meaning stabilized. That's my second example. So like that, what you are going to do is you will be given the whole periodic table. You draw Lewis dot diagrams and you find out the type of ion that each element is likely to form, except the noble gas. And then you match make, right? You can use different colors to show, okay, this one is matching that. Remember that aluminium, it is not necessary to have nitrogen. It can have chlorine with aluminium. That's very unique. But then you might ask, why chlorine? Because chlorine got 1 electron. True, but it can have 3 chlorines, bringing that 3 electrons. Okay, there are all different possibilities. So think about that.